This is question number 5 on the miscellaneous exercise, chapter 8. It says a GP consists of even number of terms. Further, it says that the sum of all terms is 5 times the sum of the terms occupying odd places. And we have to find the common ratio, as R is what we have to get. So what we can do, we know that there are even number of terms, right? So let the number of terms in total, since it is even, so we'll take it as 2n. Even are represented with 2n. Now it must be like this, the first being a and the last being, what's the last term? Last term is what? AR is to the power n, but I'll be writing here AR is to the power 2n minus 1. Why so? You know that when there are n number of terms, we write AR raised to the power n minus 1. But their number of terms is 2n, therefore, we should write, since the number of 2n number of terms, we must write this as AR raised to the power 2n minus 1. Now, in between, there will be more terms. The second term must be AR, the third term may be AR square, and so on. There must be another term in between, that is AR raised to the power n minus 1. And next to this must be AR raised to the power n, so on. And the preceding term, I mean the second last term, must be AR raised to the power 2n minus 2. This is what the terms represented here. Now let's read it further. They say the sum of all the terms is 5 times the sum of the terms occupying odd places. So first I'm writing the sum of all terms must be sum of these, that is A plus AR square, AR raised to the power n minus 1, right? AR raised to the power n, and the last term being AR raised to the power 2n minus 1, right? This is equal to 5 times. This is equal to 5 times the sum of the numbers occupying odd places. As you must be knowing, the first is odd, the third term is odd, right? And this being the even number of terms, so this is an even term. So the preceding term must be this, right? So we can write that this is equal to 5 times A plus AR square, right? First must be the name AR raised to the power 4, so on. And the last being AR raised to the power 2n minus 2. Now, we are going to apply the general formula for finding the sum of n terms. The formula you must be remembering that Sn is equal to, this is the sum as A r raised to the power n, this is minus 1 over r minus 1. That's the general formula for finding the sum of n terms. Now I'm getting the sum of this. So as you know, total number of terms is known to you, even you know A and R. So I can see that the Sn will be the sum of all terms in this case will be A, which is A here, R, which is R here, N, which is 2N here, right? For the first part, minus 1, that divided by R minus 1. And that is equal to 5 times the sum of these. So look into this, the sum of these terms, as you can see here, sum of these terms. So 5 is 5 here. Now look into this A, applying this formula, right? A is A only, but R is not R. As you can see, dividing this by this, right? If you divide this term by this term, in order to obtain the common ratio, here the common ratio is R square and not R. So we'll be writing this as A as A, R as R square raised to the power n, that means R raised to the power 2n minus 1 over R minus 1, R once again replaced by 2n, right? Minus 1. So not 2n, sorry, R is replaced by n. So R is replaced here. The common ratio is R square minus 1. Now for further simplification, what we can do, you can see from this side only that this and this should get cancelled. A should get cancelled with A. And what we can do more is to split this. Let this be 1 over R minus 1. This is 5. I can write this by applying the identity. I can write A minus B into A plus B. So you can see even this get cancelled, r minus 1 and r minus 1 get cancelled here, right? So with cross multiplication, what do we get here? As r plus 1 is equal to 5, that implies r is equal to 4. So this should be the final answer of this working.